Okay, so where the other video cut off was we were doing the question, what's the total displacement? So earlier we found the total displacement in the first 7 seconds. And when we did that, we found it to be 127.5 meters, and that was west. And we actually found the distance to be 127 meters, and the displacement would be 127 meters west. And we just finished finding the areas of these three shapes, the two triangles and the rectangle. If we add them together, 40, 60, 75 meters east. So what's the total displacement? Well, Buddy was going, maybe I'll do it up here. Buddy went 127.5 meters west. Whoops, lost the 0.5. And then he turned around and came back 75 meters east. So what's his displacement from where he started to where he ended? This distance, right? Start where the first one starts, ends where the last one ends. And when they're in opposite directions, remember you subtract them. And so when you subtract them, you get 52.5 meters. Keep the direction of the larger, the west wins. So where does he end up? 52.5 meters west of where he began. What's the total distance traveled is the next question, number 11. So to find total distance traveled, you just take the 127.5 and the 75 meters, and you just add them together because you just want the total distance. You don't care in what direction. 127.5 meters plus 75 meters. Up here it was 127.5 meters minus 75 because you have to subtract because they're in opposite directions. But here you're just looking for distance. So 202.5 meters. What is the average velocity in the first 13 seconds? Remember, average velocity is displacement over time. You can just write out delta D. I'm writing out DISP just so you remember. For velocity, it's displacement over time. In the first 13 seconds. So we just found its displacement. It was 52.5 meters. And the time is 13 seconds. So when you do 52.5 meters divided by 13, you get 4.0385 meters per second, always in the same direction. Velocity and displacement are always in the same direction. The displacement was west, so the velocity will be west. 4.0385. I'm probably keeping way too many significant digits there. Not probably, I am. It would really be 4.04. Okay, and then the next question, the average speed. So average velocity was displacement over time. Average speed is distance over time. And we found the distance. It was 202.5 meters over 13 seconds. So when you do 202.5 divided by 13, you get 15.5, we're going to say 8. I won't keep as many this time. 15.58 meters per second. Okay, and you do not need 15.58 meters per second. You do not need a direction because speed is not a vector. Did the object ever return to its starting point? Well, a few minutes ago I said, okay, Buddy started out going 127.5 meters west. Then he turned around and came back 75 meters east. Did he ever get back to where he began? No, he's still 52.5 meters west of where he began. So the answer there is no. And then the last question is describe the motion of the object. And we kind of already did this. It was starting from rest, speeding up, going west, reaching 30 meters per second west, traveling at a constant speed west for 1.5 seconds, then slowing down, still going west. Stops, speeds up going east till he reaches 30 meters per second, constant speed going east, and then slowing down going east, and then stopped again. Okay, so hopefully that helps. So what are the keys? The slope is the acceleration. So whenever it asks you acceleration, it's the slope. Velocity, at a particular time, you just read it off the graph. Distance and displacement, you have to find the areas underneath. And then average velocity and average speed, exactly like in the other one, displacement over time or distance over time. Okay, so hopefully now you can go and try the next one, graph 2, both sides of graph 2. Front side is displacement versus time, back side is a velocity versus time. And we'll go over them next day in class.